Hello and welcome to today's Pedestrian and Bicycle Information Center, Federal Highway Administration's Office of Safety, and the National Highway Traffic Safety Administration's Pedestrian Safety Action Plan webinar series. Today is the 6th webinar of this 7-part series. Today's webinar is entitled Engineering Strategies and will be presented by Charlie Zegeer, Director of the Pedestrian and Bicycle Information Center and Associate Director of Engineering and Planning at the UNC Highway Safety Research Center. My name is Dan Jeline and I'm the Program Manager for the PBIC. I'll be facilitating today's webinar. Before we get started with today's program, I want to give everyone a little information about this webinar series. The goal of the Pedestrian Safety Action Plan webinar series is intended to help communities address pedestrian safety issues and initiate the steps to drafting a tailored pedestrian safety action plan. Modeled after the Federal Highway Administration and PBIC's in-person training course, How to Develop a Pedestrian Safety Action Plan, this free webinar series covers topics ranging from funding to safety enforcement. The 7-part series was developed by the Pedestrian and Bicycle Information Center, a national clearinghouse of pedestrian and bicycle-related safety information and resources. We offer information and technical assistance to diverse audiences about health and safety, engineering, advocacy, education, enforcement, access, and mobility as it relates to pedestrians and bicyclists. Today's webinar is made possible with funding from the U.S. Department of Transportation, Federal Highway Administration, and the National Highway Traffic Safety Administration. Today's session will be archived and available for download on our website at www.walkinginfo.org/webinars. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and improving conditions for walking. These courses can be found at www.walkinginfo.org/training. Now I'm going to turn the screen over to Charlie Zegeer for the feature presentation, Engineering Strategies. And Charlie, please take it from here.
All right, Dan, thank you very much. And it's good to be here today to talk about a topic that is very important to improving pedestrian safety. And this is certainly one of the 3 E's that are discussed as part of the overall How to Develop a Pedestrian Safety Action Plan course. So we're going to go through and first talk about what are the learning objectives of this session. And basically, the idea is to describe effective engineering strategies and how to incorporate them into your overall pedestrian safety action plan. Here are some of the topics that we'll be covering. First of all, we'll be discussing crashes involving pedestrians who are walking along roadway and what are some of the effective strategies to reduce these risks, including incorporating sidewalks and shoulders and walkways into the roadway environment. Street crossings, where most of our pedestrian crashes occur. We're going to first talk about some of the human behavior that leads to these crashes, and then talk about mid-block crossings as well as intersection crossings, the incorporation of crosswalks, medians, and signals, and how they can address the problem. Then we'll be getting into some of the pedestrian-friendly intersection design strategies, looking at the roadway geometrics, corner radii, curb extensions, pedestrian islands, and then we're talking about traffic signals and different pedestrian signal-related strategies and how to make them work for pedestrians. Also incorporating the transit issues, including the locations of ideal transit stops and how to provide pedestrian crossings at these transit locations. And finally, we're going to talk about what we call road diets, or essentially creating space for pedestrians, and how to maybe reduce the amount of space for motorists along the street environment. So first, let's get into countermeasures for walking along roadway crashes. We know that walking along roadway crashes represent about 8 to 10% of pedestrian crashes, depending on the type of area. Actually, the percentage of pedestrian fatalities. Now, in rural environments, one of the more common measures that we see to reduce these crash types include paving shoulders. So having paved shoulders have been found to reduce the risk of pedestrian crashes by about 70%. And we would recommend about a 6-foot width minimum for paved shoulders in order to give pedestrians a comfortable area or room to walk along the roadway, particularly at night, where these crashes often occur. Some of the other benefits of having paved shoulders in rural areas, also they provide a space for bicyclists to ride. And research has found that providing a paved shoulder can reduce the number of run-off road motor vehicle crashes. So there's really a win-win situation by providing paved shoulders. When we get into the urban and suburban areas, the percent reduction in pedestrian crashes is even higher, at about 88%, according to some of the research we've done here at the Highway Safety Research Center. So that we really want to get pedestrians walking away from motor vehicle traffic, obviously to reduce the crash risk. We don't particularly want pedestrians walking in the road or on the edge of the roadway, where the risk is so much greater. And when we talk about designing sidewalks, some of the features that are really important are to look at the separation or the distance between the sidewalk and the roadway. It's often referred to as the planting strip or furniture zone. We're going to talk about that more in a minute. Having a planter strip provides a space for trees and street furniture. It also makes it easier to meet some of the ADA guidelines. At driveways and curb ramps, we're going to be looking at that in a minute. And it makes for a more pleasant walking environment. Many pedestrians don't like to walk on a sidewalk that was built directly adjacent to a travel lane, where they have to walk very closely to high-speed trucks and cars that pass by them. So having that separation really makes for a safer and more enjoyable walking experience for pedestrians. In terms of the width of a sidewalk, we recommend that sidewalks be built about 5 feet or even greater in width, simply because it really allows for two people to walk side by side, talk to each other. It also allows for room for people passing in the opposite direction to pass each other comfortably without having to step off the sidewalk into the weeds or grass or whatever. The actual width of the sidewalk does certainly depend on the type of area and the volume of pedestrians. We do not recommend these mountable curbs because obviously you can see what can happen from this photograph. Motorists often see this as an opportunity to drive up and park right on the sidewalk itself, which we don't want for pedestrian needs. And then when we talk about looking at the overall design of the sidewalk, particularly in urban areas, we like to break the sidewalk up into several zones. When we talk about how to provide for pedestrians, we have the curb zone, obviously the edge of the sidewalk itself, adjacent to the travel lane. We have the furniture zone, and this is where we put our trees and our mailboxes and our lamp posts, etc. Our pedestrian zone, that we want to have a clear area where pedestrians can walk in both directions and not have to undergo too much delay. And then there's the frontage zone. Typically, we talk about the zone of 2 or 3 feet directly in front of the buildings that allows room for opening doors or people that are doing window shopping to stop and browse. So these are the 4 areas for the sidewalk. And when you look at them sort of more in a residential area, this is what it looks like. You have your street, your curb zone. You can see here the furniture zone contains a fire hydrant and utility poles and signing. Your pedestrian zone, in this case, is your sidewalk. It looks to be about 5 feet in this case. And then your frontage zone may be the front yards of some of the homes with trees and bushes, etc. When you get into the more commercial area or urban area, in fact, it takes on a little bit different look. Now, next to your street, you often have your on-street parking, whether it's parallel parking or angle parking. Your curb zone here, again, and your furniture zone now can contain trees and mailboxes and signs and utility poles, whatever is needed, but to get those away from where the pedestrians are walking. You have your pedestrian zone that needs to be wide enough to accommodate your volumes of pedestrian flow, and then again your frontage zone. and you can see the door areas and other things directly in front of the buildings. They're typically meant to be out of the main path of pedestrian flow. Okay, another feature that's important when we design streets for pedestrian safety are what to do with driveways, because at driveways we see a fairly common point of conflict between pedestrians and motorists. This is a driveway design that we do not recommend. The design here appears to make the driveway look like an intersection. So to motorists, for example, this motorist making a right turn, the motorist might think that they don't have to yield the right way to the pedestrian because it looks like a street. And so oftentimes the pedestrian may be in conflict with that right-turning vehicle or even a left-turning vehicle into or out of the driveway. So this looks like too much like an intersection. It does not really accommodate a pedestrian as well as the next photo or illustration as we see here. Now this design of the driveway was really built to encourage slower speed turns by this right turn vehicle. It also has the sidewalk itself that is continued through the driveway. So it does give the appearance that the driver must yield to the pedestrian when making a right or left turn, into or out of the driveway. So these are more pedestrian-friendly designs for providing driveways that intersect with streets. Now, you can see on this photograph that it's also very important to have the sidewalk that's level to allow for walkers or folks in wheelchairs, any pedestrian to be able to go through, pass through the driveway without having to worry about encountering the steep slope. Now, if you look at this photograph, you can actually see what might be the situation, if you did not have a separation or a planting strip between the sidewalk and the roadway, that there might be some tendency to make the driveway a slope, which would be really unsafe and uncomfortable for pedestrians trying to negotiate a sloped sidewalk, and that's not acceptable. So again, having the planting strip allows you to better have a level, flat driveway for pedestrian accommodation, particularly going across the driveways. Now, there's a lot of information on how to meet Americans with Disability Act requirements for sidewalks. There's actually courses being taught by the Association of Pedestrian Bike Professionals and by FHWA. They really get into a lot of the details about how to accommodate sidewalks, walkways, trails, and facilities in general to meet the demands of all pedestrians out there, all road users on foot. We're just going to cover just a couple quick points on that, and those of you that are interested in getting a lot of the detail will need to refer to one of these other courses, and we'll ask Dan to maybe put that link to that course so those of you that want to order the course for your own jurisdictions can do that. But essentially, a couple of the key points here for meeting ADA requirements for sidewalks is we need for sidewalks and walkways to be clear of obstructions. The requirements, older requirements had a 3-foot minimum. The proposed requirements are minimum 4 feet. But we also know that sidewalks of 5 feet or greater are often needed to accommodate the pedestrian activity. We also know that sidewalks should have a smooth surface, a hard surface, hopefully that don't have to be maintained too regularly. That concrete is one of your best treatments there because they can last many, many decades, but you do want to keep your sidewalks maintained properly regardless of what the material is. We know there's also sort of a maximum cross slope, including the slope of your driveways sidewalks at driveways. That maximum slope is about 2%. We want to have a little bit of slope to allow water to run off, but not too much slope that may make it difficult for pedestrians to negotiate. Okay, now we're going to get into countermeasures for crossing the street. And we know about 80% or more of pedestrian crashes occur when pedestrians are trying to cross streets. often the high-speed, high-volume, multi-lane roadways. So we're going to look at some different issues that relate to getting pedestrians safely across streets. Now, one of the main issues is speed, the speed of motor vehicles, and we know that speed kills. We've heard this many times. And speed really relates to pedestrian safety in these three basic ways. Number one, we know that the speed of motorists affect the driver's field of vision and their ability to see pedestrians in the roadway environment. Number two, the speed of the motorist also affects the driver's ability to react and stop in time to avoid a crash. And three, obviously, the speed of motorists affects the severity of a crash if one does occur with a pedestrian. So let's look at these three different factors of speed. And you can see in this one, this represents a motor speed of about 15 miles an hour. And you can sort of see the driver field of vision is fairly broad. Motorists could see a pedestrian potentially stepping into the roadway to cross from the left or to the right fairly easily at this low speed. As the speed of the vehicle increases, you can see what starts to happen now is motorist field of vision starts to diminish. And so the motorist starts to focus their attention more on the horizon ahead. So here's an example at 20 miles an hour. As you increase speed to 25, you can see the motorist is less likely to notice pedestrians on the sidewalk or pedestrians that step out from the left or to the right. As the speed increases to 30 miles an hour, you can see that that even limits their field of vision more. So you get the idea. And when we often see crash reports involving pedestrians, and the driver is quoted as saying that the pedestrian stepped right out in front of them, or what I've seen often is they say the pedestrian came out of nowhere. Well, the pedestrian did not come out of nowhere. They came out from the driver's left to right, and the driver may have been focusing too far ahead or just not paying attention. And this can be one of the factors, one of the reasons why the pedestrian came out of nowhere, because the driver was going too fast, maybe not paying attention or looking off into the horizon. Okay, another factor that we talk about with respect to speed is the ability of the driver to stop in time to avoid a collision. And we know that some pedestrians may not all be complying with their responsibilities. Some pedestrians, children in particular, may step into the street abruptly, where a driver may be faced with reacting quickly. So this chart sort of gives the relationship between the speed of the oncoming motorist, you can see on the y-axis, as it relates to the, this should say, reaction plus braking distance. In other words, if someone appears suddenly into the roadway ahead, a driver has to react and apply the brake, and usually that's in the neighborhood of about 1 to 2.5 or 3 seconds. Some drivers can react even faster than that, maybe a half a second. So whatever distance that driver has to go in that second or second and a half, whatever it is, that's the reaction distance. And then you take into account the distance it takes the vehicle to stop once the brakes are applied. And this is what we call the braking distance. So if you add those two distances together, you have the combined reaction and braking distance on the x-axis. So if you look at that distance as a function of vehicle speed, you can see if the driver is going fairly slow, let's say 20 miles an hour, then they can stop in around 100 feet, which includes the reaction and braking distance. However, if they're going 40 miles an hour, then it takes more than 300 feet for that vehicle to come to a stop. So the key message here is if we can do something with respect to designing or retrofitting a roadway to reduce the vehicle speeds, even a few miles an hour, that can really dramatically reduce the distance it takes a motorist to stop in time to avoid a collision with a pedestrian. Okay, so the third factor in speed as it affects pedestrian safety is the relationship between the speed of the vehicle if, in fact, a collision occurs with a pedestrian, and the resulting severity of the injury of the pedestrian certainly is affected by the impact speed. So if you look to the far right of this chart, and this is based on a study that was done in the United Kingdom back a few years ago, where they were able to estimate speeds of impact by the vehicle as it struck the pedestrian. And the results show that if a pedestrian is struck by a vehicle traveling at 40 miles an hour, then there's about an 85% chance that pedestrian will die. If we can do something to the roadway, or if we can get the drivers to slow down 10 miles an hour, down to 30 miles an hour, then at least the pedestrian likelihood of death is about 50-50, about 45%. So at least you've increased the chances that the pedestrian may live. Now, if we can do something further and get the speeds down another 10 miles an hour, down to 20, then there's about a 95% chance that pedestrian will live, looking at the distribution of crashes used for this study. So, again, this is the third different way that speed can affect pedestrian safety. So getting that speed down is a critical factor in the overall issue of improving the environment for pedestrians, not only with engineering, I'll add, but certainly there are education and enforcement components to this as well to get the speeds down. So, okay, so how do crosswalks come into play? How do they affect pedestrian safety? What are the purposes of crosswalks? Well, according to the Manual on Uniform Traffic Control Devices, we know that crosswalks are typically provided at some locations to indicate to motorists where pedestrians may choose to cross. And it's also used to indicate to pedestrians where is a preferred crossing location. So it's really intended to give messages to both motorists and pedestrians. So the next question is, well, what is the effect of pedestrian-related crosswalks on crash risk? So a few years ago, we conducted a study for the Federal Highway Administration to look at this issue. And what we did is we looked at 2,000 pedestrian crossings. 1,000 had marked crosswalks, and the other 1,000 were unmarked crosswalks. And we selected matched pairs of crosswalks, where one would be at a marked crosswalk, let's say on the north side of an intersection, and the other would be on the opposite leg as an unmarked crosswalk. For each of these 2,000 crosswalks, we collected 5 years of pedestrian crash data. We collected information on the traffic volume, the pedestrian volume, number of lanes, other characteristics of the intersection, and looked at analyzing the data to determine what are the factors associated with pedestrian crash risk, and more specifically, what is the role or the influence of having the crosswalk marked compared to having an unmarked crosswalk at a given location. The bottom line is this. We found that for 2-lane roads, there was no significant difference in the crash risk, all else being equal. In other words, if you have a 2-lane road, if the question is, well, should I mark a crosswalk there or not, it's more a matter of economics. We typically don't need to mark crosswalks on our local streets or suburban streets, where traffic volumes are low and it's fairly easy to get across the street. And even on the collector streets and some arterial streets, marking a crosswalk tends to depend more on, do you need it there? Is it going to help pedestrians know where to cross? Do you need to indicate, where pedestrians are going to be crossing for motorists? So there's really no discernible crash difference that we could find on 2-lane roads. However, the issues really come into play more on the multi-lane roads, roads with 3 lanes or more, particularly on the 4- and 5-lane roadways. We found that on these multi-lane roads, as long as the traffic volume is under about 12,000 vehicles a day, there was, again, no significant difference between crash risk for marked versus unmarked. But on the multi-lane roads with 12,000 vehicles a day or more, if it had no median, crash rates were higher on marked crosswalks than unmarked. And even if there was a median, as long as the traffic volume was above about 15,000 vehicles a day, there was a significantly higher pedestrian crash risk on marked crosswalks compared to unmarked. And someone may say, well, gee, why is that? Why does it make it higher crash risk if you have marked crosswalks on these multi-lane high-volume roads. And what we found is that it really is a matter of older pedestrians tending to cross more often in the marked versus unmarked crosswalks, combined with what we call a multiple threat crash. And we're going to talk more about that later, where one vehicle stops for the pedestrian, like in the curb lane, and then the oncoming vehicle doesn't see the pedestrian until it's too late. And these happen often on multi-lane roads at marked crosswalks. So that's sort of the combination that is higher risk for pedestrians in terms of marking or unmarking crosswalks. So we're going to look a little bit more at some of those issues and how maybe you can overcome some of those crash risks through other engineering treatments. Okay, so this is what we were talking about with the multiple threat crash. We found about 17% of our pedestrian crashes occur on multi-lane roads where you have a marked crosswalk and 2 or more lanes in each direction. And you can see in this illustration, the vehicle in the right lane stopped for the pedestrian. The pedestrian saw the vehicle stop, did not necessarily think that there may be an oncoming vehicle in the second lane, and the driver of that white vehicle could not see the pedestrian because his or her view was blocked by the stopped vehicle. So what happens is the pedestrian steps in front of the stopped vehicle and then doesn't notice the oncoming vehicle in the second lane, steps in front of that lane, and is struck. Now, the driver of that second vehicle will say the same thing, that, gee, I didn't see the pedestrian until they were right in front of my car or truck. And so this is what we often refer to as the multiple threat crash. So there are some solutions to this kind of crash on a multi-lane road. We're going to talk about one of those in just a minute. Okay, so getting back to the study recommendations, again, to go over what we found is that it is okay to mark a crosswalk on 2-lane roads. It doesn't really increase the crash risk. But on the multi-lane, higher volume roads, this is where we have to be careful. So don't just put paint alone. Don't just mark a crosswalk on these higher volume roads with multiple lanes unless you have some other pedestrian enhancements. And we're going to talk about some of those other enhancements that may be beneficial. Okay, so at locations where it is okay to have a marked crosswalk, there are some other things that can be used to go along with them to make them safer. Certainly choosing the proper location for the crosswalk, making the choice whether they should be the high visibility markings. We'll tell you more about that in a minute. Should there be illumination or overhead lighting? What kind of supplemental signing? Should we use advanced stop bars? What about median islands? You know, when and where should they be used? We're going to talk about curb extensions and what those are. And then finally about adding signals to the crossings themselves. So let's look for a minute at crosswalk markings. And you know, if you're a pedestrian, you might be looking at a crosswalk like this, and a pedestrian can see that marking, even though it does look a little worn. And the question is, yes, but can an oncoming motorist see that marked crosswalk? And you might be surprised to know that this is the same marked crosswalk from the viewpoint of the driver. And I don't know about you, but it is fairly difficult, if not impossible, to even see that crosswalk. So the point here is if you're going to mark a crosswalk, it needs to be visible to motorists. Don't just put it down there and let it fade away, as was the case here. So there are several different types of crosswalks that can be used. The one on the top, obviously, we call the parallel line. The ones in the middle and bottom, we often call high visibility crosswalk. The one in the middle we actually sometimes refer to as continental style. The one on the bottom is the ladder type marking. So either the middle or the bottom one certainly has more paint, much more visible to motorists. And so we know of cities that have tended to go primarily with the high visibility crosswalks for pedestrian concerns. Even though they may be more expensive to maintain, some of them really can last much longer and can improve the visibility to motorists. So let's look at the continental style. This particular type was constructed with a placement of the markings to straddle the wheel paths. So you can see the vehicle on the left there, as it passes through, the wheels are not even going to go over the stripes because of the pattern, the way that they have placed the crosswalk stripes. So cities like Orlando, Florida have gone to this type of crosswalk marking pretty much at all their markings, and they claim that it lasts much, much longer than this traditional parallel line crosswalks, as well as being much more visible to oncoming motorists. Okay, here's an example of a supplemental sign that is often used. It's currently in the Manual on Uniform Traffic Control Devices, and it is intended to give motorists an extra warning or message that pedestrians may be crossing. And the one on the left says state law, yield to pedestrians when within crosswalk. The sign on the right says state law, stop for pedestrians within crosswalk. And the choice of which sign is appropriate depends on the wording of the pedestrian crosswalk law in a given state. Some states require motorists to yield to pedestrians in crosswalks. Other state laws require motorists to stop. So depending on the wording of the state law, that would determine which of the two signs would be used. Okay. Now another device which we often see more often now than in the past, it's a fairly new device called the rectangular rapid flash beacon, or the LED beacon. And even though it was not included in the 2009 METCD, it has gotten interim approval for use from Federal Highway Administration. And essentially it is a pedestrian crossing sign with a down arrow. And you can see between the sign and the down arrow there's a little light that sort of flickers back and forth. We call it the wig-wag flashing light. And this device has been found in research studies to increase the percentage of motorists who yield to pedestrians from about 20% in the before period to about 80% in the after period. And generally the beacon is located between the warning sign and the arrow plaque, but it must be pedestrian activated, usually with a push button. And you often see these on multi-lane roads, and when used on multi-lane roads, you should have one in the median if there's a median island, so the motorists can see the sign either on the right side or the left side of the road. I've even seen them when they have them on the right side, the median, and the left side of the roadway. But they have been shown, at least tentatively, to really improve pedestrian crossing in terms of improved yielding behavior by motorists. Okay, let's get back to the issue of advanced stop and yield lines and this multiple threat crash. And this is a fairly low-cost solution to deal with that multiple threat crash that we talked about before. So where you have a 4 or 5 lane road and you really want to provide a marked crosswalk, are there other supplemental treatments that can reduce the crash risk? There is evidence through some recent research, Dr. Ron Van Houten and others, that indicates that if you have a situation like this, and again, you can see car A in the right lane to stop right at the crosswalk. Car B is coming up from behind, and that driver of car B may not be able to see a pedestrian that steps off the curb there on the right side. And so it's kind of setting up the potential for that multiple threat crash. So you can see if you move that stop line or yield line back about 30 feet or 20 to 50 feet, I think is what's currently allowed in METCD, then that opens up the line of sight for the driver of vehicle B. So now the driver of vehicle B can see that pedestrian from much further back. And not only that, but the pedestrian that stepped off the curb can glance to the left and much more easily see the second car coming. So either the vehicle has time to stop or the pedestrian has time to take evasive action, or both. So you can see how you can reduce the threat of that multiple threat crash. And then to go along with that stop line, you would need to have signs like you see on the right side, stop here for pedestrians, or like you see on the left in the case of the yield law that would say yield here to pedestrians. Now where you have a yield law in a given state, you don't use the solid bar as the advanced stop bar. You use these little triangles. We call them the shark's teeth. So the shark's teeth or yield line would be used in conjunction with the yield sign that you see in the upper right-hand corner of your slide. It would say yield here to pedestrians. Okay, so that would be normally placed about 30 feet on the advance of the marked crosswalk. Okay, so here's some treatments, and here's an example in this next slide. You can see of when the stop here for pedestrian sign is used with a solid line. And that line may not be quite far enough back, but you can sort of get the gist of the idea and what more states are starting to use on the multi-lane roads where they do want to indicate a marked crosswalk for pedestrians. Okay, now let's talk a little bit about raised medians and median islands. And research has shown that you can reduce pedestrian crashes by about 46% by installing raised medians or median islands at marked crosswalks, and almost as much, about 39%, if it's an unmarked crosswalk. So on multi-lane roads, raised medians are your best friend in terms of pedestrian safety. And let's look at some examples here. This just kind of shows a continuous median island. So the basic principle is that you want to break up that crossing movement for pedestrians into 2 steps. Instead of a pedestrian having to cross all 4 lanes or 5 lanes at once and trying to find the gaps in traffic to the left and to the right, all a pedestrian have to do here, if there's a raised median island, is look to the left, wait for a gap in traffic, cross to the median, and then once they get there, then look to the right and then find a gap and cross the second half of the street. Okay, so you can see a pedestrian choosing a gap, crossing the median, and this kind of illustrates what would happen, with a curb extension. Same principle. You break up the crossing, whether it's the full median island, full median or the crossing island, as you see here. Okay, the same principle. I will say that it really needs to be a raised median or median island. You can't just have a painted median. We found through some of our research that simply having a painted median does not offer the same kind of protection to a pedestrian that you would have with the raised curbing or the raised medians or median islands. And this is an example where they've actually veered the island opening to the right. And the idea here is that once pedestrians get to the middle of the street, then you want to direct them to the right if you have room to do this, so the pedestrian would be sort of forced to look at oncoming traffic to their right instead of just assuming that it's still clear. We want to sort of build that into the geometrics to encourage pedestrians to look to the right and make sure that there's no traffic oncoming before they step into the second half of the street. All right, so we talked about some geometric solutions. Let's look now at some examples of how pedestrian signals can enhance crossings for pedestrians. One of the things that you may have seen as you crosswalks in different cities is what we call a hot response button. And this is where you have a marked crosswalk that has been instrumented with a traffic signal and a push button, so that when a pedestrian pushes the button, it immediately goes to an amber and to a red for motorists, and then as soon as the red comes on to motorists, the pedestrian will see the walk signal. The reason for having what we call a hot button is because if a pedestrian has to push a button and wait for a long period of time, many pedestrians won't be willing to wait that long. They may just try to cross the street anyway. So that's not what you want in terms of providing for pedestrians. So then the signal essentially becomes very inefficient. Okay, let's look at now a variation of a traffic signal with a pedestrian signal. We're going to talk about a 2-stage crossing and how this can really improve the effectiveness of the signal for pedestrian safety and minimize vehicle delay. Okay, so what you see here is you see a divided roadway. There's a pedestrian island. You've got crosswalks that are staggered. The pedestrian on the bottom of your screen would push the button, wait for the signal to turn red for cars. Immediately, we give the walk indication to pedestrians, so pedestrian would cross to the island. Now, while that's occurring, traffic in the upper part of the screen, coming from right to left, still has the green light. So flow is maintained from right to left, while traffic coming from left to right is stopped. So pedestrian now walks to the median island. Okay, step 2. Now the signal has given a pedestrian enough time to get to the island, and then it releases traffic coming from left to right, while a pedestrian is walking in the island itself toward their right to go to the push button to push to get the walk signal to go to the second half of the street. Meanwhile, traffic coming right to left continues to flow. Pedestrian now pushes the button, and traffic from right to left is stopped on a red light, and pedestrian can cross the second half of the street. Meanwhile, traffic from left to right at the bottom of the screen has continued. So basically, you have gained pedestrian safety by stopping traffic in each direction for the pedestrian to cross safely. And at the same time, you have really minimized vehicle delay, because vehicles only delayed a few seconds coming from left to right, and then later coming from right to left. So you maintain the efficiency and movement of your traffic flow pretty much, while incurring some improved benefit to pedestrians crossing the street. Okay, I hope everybody understands that sequence. And those treatments are often used maybe in a suburban area where you have bus stop locations. It's fairly common, and it's fairly efficient for motor travel. Okay, so countermeasures for intersection crashes. These are fairly common in urban areas in particular, and some of the basic principles about pedestrian safety intersections is we want to keep the intersections tight. We'll explain what we mean by that. Simple, kind of squared, not a skewed intersection. Fairly low speed, easy to understand, and we want to avoid free-flow movements if we can. We want to reduce the conflicts between right and left turn movements to improve pedestrian safety overall at those intersections. Okay, so let's look for a minute at the curb radius. And we can see the curb radii at the top of the screen are fairly tight. In other words, there's a fairly tight turning radius compared to the bottom part of your screen. So you can see vehicles coming from the bottom of your screen making a right turn can make that at a fairly high rate of speed because of how wide that turning radius is. And that really makes it difficult for pedestrians because now they have to contend with these really high-speed right-turning vehicles on a green light. And another factor is when you have the real wide turning radius is look at the width of that crosswalk on the south side of the intersection. You can see how wide it is compared to the crosswalk on the north side of the street. And that's all because of the corner radii that were designed very wide on the bottom part of the intersection and fairly tight on the top of the intersection. So the disadvantages of pedestrians are not only the high-speed right-turn vehicles, it's also the much greater length of crosswalk they have to cross on the south side of the street due to the wide turn radii compared to the north side. Okay, so geometrics can really matter in designing intersections for pedestrians. Now, we do need to consider large vehicles like buses and trucks that need to make those turns, but particularly when these large vehicles are turning from or to directly into a two-lane receiving leg of the intersection, that these can still be accommodated in many cases with a fairly tight turning radius. You can see the turning radius there in the middle of the screen is very, very tight. And still a bus is able to make that turn, even though it does take up both lanes of the receiving leg of the intersection. Still, that's a fairly safe maneuver, and also keeps that crossing distance short and keeps that right turning speed of the vehicle fairly low. So again, this is what that would look like even with a large bus making that right turn. Okay, now another measure that can be used to help shorten crossing distance and better accommodate pedestrians at an intersection are what we call a curb extension. And again, looking at this is sort of a before condition sketched out here, a 58-foot crossing distance for pedestrians. And if we were to retrofit that with a curb extension, it would really dramatically reduce the crossing distance of the pedestrian. And it has several benefits to pedestrians. Number one, there's better visibility. So a pedestrian standing on that corner at the upper part of your slide, either on the right side or left side, can much more easily see motorists coming than we had in the previous slide. Secondly, The curb extension can act as a traffic calming measure and slow down the speeds of vehicles, which can benefit pedestrians, as we talked about. And third, having that curb extension can even provide room for street furniture, for small trees, for mailboxes, even for bicycle parking and other amenities that you might want there on your street. And one point here is that the curb extension should be essentially the width of the parking lanes and not really encroach into the bike lane. So you can see bicycles coming from the south to the north still have enough room to go through that intersection with their bike lane maintained. Okay, so this sort of shows a photograph of what that would look like. We have a pedestrian there on the upper right wanting to cross the street, where they may or may not be able to see around the parked cars. On the south side, if you add the curb extension, you know that's a preferred measure, and it goes out generally to the end of the parked cars. Now, another measure that can be used at intersections are islands, and you can see some of the benefits of raised islands is they separate conflict points. So if a pedestrian were trying to cross the street in the upper right-hand corner, where they have that free flow lane, the island really limits that width so that a right turn vehicle, even though it is a free flow right turn lane, the pedestrian could negotiate that lane fairly easily in a gap to right turn motorists, or hopefully the motorist would yield to the pedestrian crossing to the island. Then the pedestrian would have sort of a shorter distance across from that large island to the second island or across the street. So it does shorten crossing distances, improve sight distance, reduces crashes, and can allow you to improve your signal timing to make it more efficient for motorists and pedestrians. Okay, this is sort of a depiction of sort of the wrong way to design your slip lane, your right turn slip lane on the left. The design on the left allows for a fairly high-speed right turn movement by motorists, and their vision is really far to the left, where a motorist in the left image might be looking for oncoming traffic to the left, and less likely to be focused on the pedestrian that may be crossing in the crosswalk. The design on the right has a tighter angle, so the motorist is more likely to be able to see the pedestrian now crossing to their right, and they're much more likely to be approaching that crossing at a slower speed. So the visibility is much better to the pedestrian, and the speed will be reduced. So this is like a 55 to 60 degree angle between the vehicle flowing from the south to the north and making their right turn. So it is really important and critical that when you do have this kind of right turn slip lane to design the crossing properly. Okay, now we're going to look at countermeasures for signalized intersection crashes. Many of the cities in the U.S. Were built maybe a decade or two ago with traffic signals without having walk, don't walk signals. So what we have ended up with in some of our cities, some of our intersections, are this kind of situation where you have traffic signals and the pedestrian may or may not be able to even see those signals. And in this case, there was no walk, don't walk signal. So the pedestrian may not know when it's their turn to cross the street. Or in some cases, even if the pedestrian can see the traffic signal, they may approach the signal where there's a green light, and they don't know how much time they have left and whether they have enough time to be able to step into the street and cross before the signal goes to amber and red. So pedestrians are really faced with a dilemma about not knowing if it's safe or appropriate for them to cross since there's no signal. And so what we recommend is that agencies find those locations that have traffic signals without pedestrian signals and consider adding, retrofitting pedestrian walk, don't walk signals to as many of those as possible. Maybe set a priority system to identify the signalized intersections that are in most need of having pedestrian walk, don't walk signals, with countdown signals, of course, and to install them at a proper location. And this illustrates sort of the appropriate place for a pedestrian signal, the appropriate height of the don't walk signals as being about 7 to 10 feet. Okay, next, as many of you know, the National Committee on Uniform Traffic Control Devices has now mandated that whenever you install new don't walk signals, that they be of this type, what we call the countdown pedestrian signal. And that not only gives the hand or the walking man symbol, but it also indicates how much time a pedestrian has to cross the street. So the traditional signals have the pedestrian walking signal when it's appropriate for pedestrians to cross, then the flashing hand or the flashing don't walk when pedestrians need to clear the intersections but not step off the curb, and then the solid hand, steady hand, or the steady don't walk, which indicates they should not be in the street. So now, since we have a mandated new countdown signal for all new installations, some of the research has shown up to a 25% reduction in pedestrian crashes going from the traditional don't walk signals to the countdown signals. Okay, now we're going to talk a little bit about the proper use of pedestrian push buttons. And the MUTCD currently recommends that when you do have push buttons, in other words, when you have signals where pedestrians activate the walk signal only by push button, it doesn't go to a walk signal every cycle, that you identify locations close to the crosswalk, the center of the crosswalk, or the landing of the crosswalk. In other words, in those sort of tan areas there on this sketch, those would be candidate sites for putting the push button at intersections where you would be installing the push button signals. Okay, that makes sense? You know, not all of our intersections have the two crosswalks. Some of them only have one crosswalk location, but we recommend two crosswalks, separated crosswalks. Okay, now another issue concerning traffic signals and safety is whether to provide a protected only left turn phase to your signal. And what we're talking about here, actually knowing that separating the left turn movement from pedestrian crossings can reduce pedestrian crashes up to 70%. So here's an example of it. Essentially, the pedestrian at the top of the screen is going to try to cross from top to bottom, and the red circle or the red left turn vehicle is going to try to make that left turn, which conflicts with that pedestrian movement going from top to bottom. So what would happen in this situation when the light turns green is the pedestrian would be walking because the pedestrian would have the walk signal. Then the red vehicle at the top there would be waiting for a gap in traffic for those blue vehicles coming from south and north, and then making that left turn across the pedestrian's path. So you can see what could be created by that conflict. So after the vehicles pass to the north, then the left-turning vehicle may not see the pedestrian and then possibly strike the pedestrian when making the left-turn movement. So that can be sort of the problem that you run into there. And so you can see a collision can occur. So that is a fairly common crash site where you do not have the protected left turns. A protected left-turn movement, as you see here, operates differently. So now the left turn, the vehicle would get a green left turn arrow in this case. So the left turn vehicles would have a separated movement, and the pedestrian would be held until that movement is finished, and then the pedestrian would be given the walk signal. Okay. Now so this would eliminate or drastically reduce the chance of that kind of left turn collision. Okay, so you can see in this case the protected left turn would make that movement, and then there would be a green light to the through vehicles, and the left turn vehicles would get the red left turn arrow, which means they're not allowed to make that left turn, and pedestrians would be crossing parallel to the through vehicles. Now, of course, there is also the possibility of a right turn vehicle striking the pedestrian that's crossing Okay, so now a protected permissive is kind of a combination of the two. Initially, motorists are given a red light, and then the left-turn vehicles are allowed to turn left on a green arrow. Pedestrians are held up, and then the signal goes to a flashing arrow or a yellow arrow and then a flashing arrow. Those left-turn vehicles are completed their movement, and then pedestrians are released, and then the left-turn vehicles get a green ball or a flashing left-turn arrow now. And so there still could be some conflict between those vehicles and the pedestrians. So that's not as good of a control as a fully protected left-turn movement. But you can see that can still occur with a vehicle turning left on a green ball or a flashing yellow arrow. That crash can still occur, although not as often as if you have a permissive-only signal. Okay, so some of the solutions are to provide the protected permissive by default, but revert to a protected only when the pedestrian button is pushed. In other words, if a pedestrian pushes the button, then it will not allow the left-turn movement to cross the path. Okay, so and now we have the flashing yellow arrow, which still can create that conflict. So in heavily traveled downtown areas, it certainly is better to have fully protected movements for pedestrians, so the left-turn motorist doesn't have to conflict with pedestrians. Another measure at signalized intersections is to use a fairly short signal cycle so that you don't have stacks of pedestrians waiting to cross the street. Because having a long signal cycle can also increase pedestrian delay. Pedestrians get tired of waiting and then impatient and just cross the street against the light, and that's not a good thing for safety. Okay, now in downtown areas where you have a lot of pedestrians using the crosswalks, the pedestrians should get the walk signal every cycle. They shouldn't have to push a button. So that's something to consider. Okay, then so what we're saying here is set the pedestrian signal on recall so that whenever motorists get the green light, in this case going north-south, pedestrians will get the walk signal going in a similar direction, north-south as well. Okay, one other type of signal cycle we're going to talk about, actually a couple different ones. This one's called the leading pedestrian interval, and it essentially gives pedestrians a head start. It looks like a regular signal to drivers, and you can see here is the walk signal comes on about 3 seconds prior to releasing vehicles on a green light. So in this instance, the pedestrians would get the walk signal while their parallel vehicles, left-turn vehicles, has a red light. So it gives pedestrians a fighting chance to get across the street before vehicles are released. And this is becoming more and more popular that we've seen around the country. Another signal phasing is called what we call barn stands or exclusive pedestrian phasing. We also call it scramble timing sometimes. And essentially you can see that pedestrians are allowed to cross in any direction, including diagonally, during one cycle or one phase each cycle, while traffic is stopped in all directions. So the good news here is some of the research that has been done shows a significant reduction in pedestrian crashes overall at the intersection. The problem is that there is excessive delay in many cases to the pedestrian and the motorist. So for these things to work, it needs to be installed in heavily traveled downtown urban intersections with a lot of pedestrians with moderate to low volumes of motorists. And it has to be installed in cities where pedestrians are fairly compliant. Because if pedestrians are violating the signal, then you really can have safety problems. Okay, the other issue we want to talk a little bit about is pedestrian crossings at transit. And we want to make sure that where we do have transit stops, that there are reasonably safe ways or places for pedestrians to cross, either right there or nearby. So you can see here on a 2-lane road, we talked about having marked crosswalks on 2-lane roads, how it is relatively safe for pedestrians. And what they've done is they have placed the crosswalk behind the bus. So the bus that came from left to right is now stopped at the transit stop. People get off the bus, walk behind the bus to cross the street. And so those pedestrians can now see motorists coming from the left fairly easily. And they get across the street. The speeds here would be fairly low. The volumes look to be probably fairly low. So this is a very appropriate crossing at a transit stop and well designed. You can see in this instance, because you want to make sure that the bus pulls past the crosswalk and doesn't stop right in front of the crosswalk. Because if it stops in front of the crosswalk, then the sight distance will be blocked between the pedestrian and oncoming motorists by the bus itself. Okay, one of the other treatments we're going to talk about is road diets. And here we're talking about restriping a roadway from a 4-lane undivided roadway, which traditionally has high crash rates, to a 3-lane design. So what that would involve is, as you resurface the street, instead of having 2 lanes in each direction, which can result in a lot of those multiple threat crashes, also a lot of high crashes to motorists. 4-lane roadways typically have high crash rates overall. But it would then yield something like this, where you would now have room within your right-of-way to have on-street parking, to have a center 2-way left turn lane, to add bike lanes, to have median islands. You can even widen the sidewalk. So it really redistributes the space between the right-of-way, and it's much safer for all road users. Here's an example that shows a before condition of a 4-lane undivided roadway in Charlotte, North Carolina, and you can see what it looked like before. This is an artist's rendition of what it would look like with a median island. And here's an actual photo taken after the road diet conversion with the raised median islands. Here's an example of a 4-lane roadway converted to a road diet. They took 1 full lane, converted it to on-street parking, curb extension, and a bike lane. And some of the benefits of road diets are reduces crossing distance for pedestrians, reduces the chance of that multiple threat crash, provides room for a crossing island, so you can break up the crossing into 2 different steps. So you have the safety benefit of the crossing island plus the reduced crossing distance. It reduces the top-end speed because the speed on the roadway is governed by the speed of the slowest vehicle in the traffic lane. And it also allows for wider sidewalks, bike lanes, on-street parking, and it can reclaim space for other uses. And this treatment has been found to reduce total crashes, motor vehicle and all crashes, by about 29%. So it's really a safer roadway design for all road users. Okay, so in summary, what we talked about includes some of the strategies that can help improve safety for pedestrians, the sidewalks and walkways along roadways, so understanding some of the human factors that come into play with getting pedestrians across the street, things like when to add marked crosswalks, median islands, signals, what are some of the pedestrian-friendly intersection designs, like tight turning radii, curb extensions, and pedestrian islands, and what are some of the different traffic signal options that can be used to help pedestrians where there are traffic signals. And finally, the road diet improvements. So all of these are different options that can be used depending on your roadway conditions and your crash characteristics to improve pedestrian safety. Okay, so finally, we've tried to address the learning objectives of describing some of the engineering strategies and how to integrate them into your pedestrian safety action plan. So Dan, that's all I have at this time.
All right, well thank you very much, Charlie.